Okay, hi guys. So today we're going to be talking about logic gate, and these are the topics that we're going to be going through in this lecture: the inverter, the AND gate, the OR gate, the NAND gate, the NOR gate, the XOR gate, and the XNOR gate. So let's get started. Alright, guys. So the first logic gate that we're going to be talking about is the inverter. So in this, basically, it performs the NOT operation, and the Boolean expression that can be shown with an is with an overbar on the input. So you can get it as x equals to a bar, which is also known as a complement. And this is basically the logic gate for the NOT. This is the NOT gate, and we can like derive a truth table from this. And you guys know that when we're making a truth table, uh, we basically use the formula x equals to 2 to the power n, and n is the number of the inputs. So the NOT gate only has one input, so we're just gonna have x equals to 2 to the power 1, which is we're only gonna have two inputs. So which is like, if you input a 0, you're gonna get a 1 as the output, and if you get input 1, you're gonna get a 0 as the output. Now if you wanna like apply a NOT gate onto a binary number, here's an example of how you can solve it. So we have the binary number 11001110. So we're just gonna apply the NOT gate onto each and every input. So we have 1, which is going to turn into a 0. The 1 is also going to turn into a 0. The 0 is going to turn into 1, 1, 0, 0, 1. Right, so now we can also make a waveform from this, which is like, if it's high over here, going to be low as the output. If it's low over here, we're gonna get a high output. If it's high input, then a low output. If it's a low input, then a high output. So you can also like, right. So the next gate that we're going to be talking about is the AND gate. In the AND gate, it performs the multiplication operation, and the Boolean expression is usually shown with a dot between the two inputs. So you can get x equals to a dot b as the Boolean expression, and this is uh, the logic gate for AND. And the truth table which we're gonna get is by x equals to uh, 2 to the power n, and there are two inputs, so we're gonna get x equals to 2 to the power 2, which is 4. So we're gonna have 4 inputs in total as in our truth table. So you can get the output like this. If you have 0 and 0 and you multiply these two, you're going to get a 0. If you multiply 0 by 1, you're still going to get a 0. And if you multiply 1 by 0, you're going to get a 0. But if you multiply 1 by 1, you get a 1. So you're going to get a high output in this one. So if you want to create a waveform, you can create it like this. 0 multiplied by 1 is 0. 0 multiplied by 1 is still 0, so you're just going to continue this. 1 multiplied by 1 is 1, so it's going to be a high output. 0 multiplied by 1 is 0, low output. 0 multiplied by 0, low output. 1 multiplied by 0, low output. 1 multiplied by 1 is a high output. So that's basically just the waveform. And this is one question, that if you're gonna and two binary numbers, what will be the output that you're gonna get? So the question is basically 1 1 1 1 multiplied by 0 1 0 1. So this is the AND operation, and you're gonna get 1 multiplied by 1 as 1, 1 multiplied by 0 is 0, 1 multiplied by 1 as 1, and 1 multiplied by 0 is 0. So your output will be 0 1 0 1. Now let's move on to the next gate, which is the OR gate. Right. So in the OR gate, it performs the addition operation, and the Boolean expression is shown by with a positive or plus sign between the two inputs, and this is the gate that we use to represent the OR gate. Right. So the truth table that we're gonna get from this is 0 plus 0. Let me just write it here. 0 plus 0, you're gonna get 0. 0 plus 1, you're gonna get a 1. 1 plus 0, you're gonna get a 1, and 1 plus 1 remains 1. Right. So you can make a waveform through this also, like 0 plus 1 is 1, 1 plus 1 is 1, 0 plus 0 is 0, 0 plus 1, 1, 1 plus 0, 1. So you can tell that you're only gonna get a low output in the OR gate when you have two zeros. If you have even one uh, high input, your output is gonna be 1. Right, so we have an example question over here, which is that if you or two inputs, A equals to 1 1 0 0 and B equals to 0 0 1 0, what would be the output for this? So let's just try to solve this. It's pretty easy. 1 1 0 0 or it with 0 0 1 0. You're gonna get a 0 1 1 1 as